Hello everybody. Okay, so in this video we are looking at an application of first order difference equations. And an application or common application of a first order difference equation would be loan repayments, right? So an application of first order difference equation is loan repayments. The balance for the next month depends on the current balance and interest applied minus any payment. So what does that mean, right? Your loan repayments, right? You repaying a loan. Well, what happens in a loan is you pay money off your loan. The bank charges interest and adds interest on to your previous month. And then that's your balance then for next month. Then you pay it off, they add interest, that's your new balance. You pay some off, they add interest, you pay, that's your balance. So, right, let's have a look here. See how we can model it. Sarah took out right. There you go. Oopsie, oopsie, poopsie. Right. So Sarah took out a loan. Sarah took out a loan of 15,000 to renovate her home. She will repay the same amount B at the end of each month for 48 months at an interest of 0.75% is applied to the amount she owes every month. So let Vn be the amount Sarah owes at the end months and V0 equal 15,000. Write down and solve the recurrence relation for Vn. So, right? We need to now first create my first order difference equation. And what's happening now? So my balance, Vn is the amount she has left on her loan. And what do we know? It is her previous month, so Vn minus 1, right? After interest applied. So the interest applied is 0.75%. So it's going to be 1 plus 0.75%, which is 0.075. Right? So 0.75 divided by 100. No, it's even, sorry, it's going to be even. 0.075, right? It is tremendously small. Right? And then we are subtracting my monthly repayment fee. So Vn is going to be equal to 1.0075 previous month minus B. So let's keep going. So V0 is 15,000. Grand. Her next month, what's happening next month? Well, she's charged interest 1.0075 on the previous month. And then she makes a payment. B2 going to be 1.0075 times the previous month. B, and then subtract the repayment then for month 2. Month 3 going to be 1.0075 times the previous month. Actually, first let's expand out V2 actually. So this is going to be 1.0075 squared times 15,000 minus 1.0075B minus B. So V3 is just going to be 1.0075 times all of this. So it's going to be 1.0075 cubed times 15,000 minus 1.0075 squared b minus 1.0075b, and then finally I subtract my repayments. So I notice this is a geometric series, right? This is a geometric series minus b minus 1.0075 b minus 1.0075 squared b. This goes on forever and ever and ever. So it's a geometric series. So a times 1 minus or the end, all over 1 minus or. A being minus b, or being 1.0075, and then finally n just being n. So it's going to be minus b times 1 minus 1.0075 n all over 1 minus 1.0075. So 1 minus 1.0075 is minus, this is going to be here, fine. So this here is going to be minus b, 1 minus 1.0075 n all over minus 3 over 400. And then we bring this down here. We make that 1.0075 n times 15,000. Flip and multiply this sum. It's going to be 1.0075 power of n. It's 15,000. This here, the minuses here will cancel. So I'm left with then plus 400b, well, 400 over 3b times 1 minus 1.0075 to the power of n. 1.0075 n times 15,000. Plus, actually, no, I think we're done here, really. We can't really expand it anymore. We have a b, right? So that's actually expanded out enough for what we need. We don't know what b is. We don't know what repayment is. But what we do know is calculate the value of b so the loan is repaid in full after 48 months. So the loan is repaid in 48 months. We want to calculate what b is. So that means n is equal to 48. And T48, my term value of 48 is going to be 0, or V, or should I say V. So she will have no money then to earn. Sorry, not earn. She'll have no money to pay back at the end of 48 months. I'll have 0 is equal to 1.0075 power 48 times 15,000 plus 400b over 3 times 1.007, 1 minus 1.0075 to the n. Well, the n in this case is 48. Right, we need to get b on its own. So bring things over. Minus 1.0075 to the power of 48 times 15,000. Times 15,000 equals 400 over 3b times 1 minus 1.0075 to the power of 48. So I need to get b on its own. So I am going to divide the other side by 400 over 3 and 1 minus 1.0075 to the power of 48. It's going to be minus 1.0075 to the power of 48 times 15,000 all over 400 over 3 times 1 minus 1.0075 power 48. And that is equal to B. And so you put all of this in your calculator. Minus 1.0075 the power of 48 times 15,000. 400 over 3 times 1 minus 1.0075 the power of 48. And we get here, and you put this into the calculator. €373.3. 373.3. That is the answer there. And that's how much her monthly repayments was. Right, so I hope this video was some help to you guys. And I'll catch you guys later. Bye.